Hello students, next we look into the reciprocity theorem. What the reciprocity theorem states is that in a linear, bilateral, active, single source network. Now this whole what do you say sentence we have to understand properly. Okay, because the reciprocity statement is only for this kind of a network. What is that? First, it is linear. Linear means it is not having any diodes or transistor or anything like that. Okay. Bilateral means that circuit in which current can flow in both directions. That means a DC as well as an AC circuit. Okay. Bilateral means basically current can flow in any which direction. So it's basically a AC circuit. AC or DC also. Then active means only active components are present. Okay, that means there is no dependent source, only independent sources are there. Then single source network, it means there can be only one dependent source. So when we say in a linear bilateral active single source network, you should understand all of this. Okay, so in such a network, the ratio of excitation to response remains the same when the positions of excitation and response are interchanged. And that is what is reciprocity. What is the meaning of that? The meaning of that is, suppose we are having such a network. I have not drawn the network here. I have put the whole network inside a box. And that network is a linear bilateral active single source network. Such a network, if suppose there is only one source and suppose that source is this. Now it can be voltage source, it can be current source. Okay, it can be a voltage source, it can be a current source, whichever be the case. So here we are having the voltage source. So in such a voltage source, because of this voltage source, in some branch somewhere there is a current flowing in this direction. Okay. Then what reciprocity theorem says is that if you are going to interchange the position of the voltage with the position of the, now here we are not saying current because voltage is called as the excitation. Excitation. What is the meaning of excitation? Some element which gives power or which excites. Okay, so this is the power source or which is the called as the voltage source. It can be a voltage source or a current source. So it is called as excitation. And because of that excitation, there is some response, and that response is the flow of current in this particular branch. So this is response and this is excitation. Okay, clear? So what it says, what the reciprocity theorem says is that if you are going to interchange the excitation and the response position, that means you take the excitation the other side and you take the response the other side. So response is the current and you calculate that current will always be equal to this current. So even if you change if you interchange the position of the excitation and the response, okay, if you interchange them, you will get the same value. I've just drawn a circuit here and not put the values and all. Suppose if I want to find out, because of this voltage there is some current here. Okay, if suppose I find out that current, if suppose I found out that current because of this voltage, then let that current, so let me write that, let that current be some I2. Okay, so I have drawn this direction like this. Okay, then what it tries to say is that if you interchange the position, so let me interchange the position and redraw the circuit. So here I am taking the voltage source, rest I am not changing anything, and wherever the arrow was, there I am going to put this. Now look, I am going to put this in such a way that the direction, look at the direction where I am going to place it, how I am going to place it. This one goes from, arrow is going like this, arrow is going in this direction. I will always place the positive and the negative of the battery like this. Okay. Okay, this you have to be very careful. This is the positive plate and this is the negative plate. I am going to place the positive and the plate in such a way that the current direction is from the positive plate to the negative plate. See, I am talking about placing the battery like this. Okay, when the current is drawn like I2, instead of I2 I am going to place the positive and the negative like this. This you have to take care, otherwise you may make a mistake. And then rest of the circuit I am drawing as such. Now because of this I am going to get some current. Because of this I am going to get some current. So again I have to draw the current. How will I draw the current here? Again I will draw from positive plate to negative plate, inside, from positive plate to negative plate. So that I will draw it like this. And this current will be, I will name it as, let's say, I3. Then what reciprocity theorem says is that you try to do this, you will get I2 is equal to I3. Where people make a mistake is how they place this. See, if I would have, instead of drawing like this, if I would have drawn the current, the opposite direction, okay, suppose I would have asked to find this current, then I will not place the battery like this, but since it's going from here to here, I will place the positive plate from where the current will start and the negative plate where the current ends. And then here again, since this is the positive plate, so it will start from the positive plate and go down. So this is going to be the direction. So if this is I2 and this is I3, again I will say that I2 is equal to I3. Okay. So how is the question asked? Tomorrow I will put another question and you will understand it much better. But basically what question comes is, prove the reciprocity theorem for, they will give a network and they will ask you to prove it. So you will have to find out the current I2 and you will have to find out the current I3 and then interchange it. Now instead of current there can be voltage also. Let me draw that one also. Instead of current there can be a voltage also. For example, let me redraw this. So I am interested to find out, wait, okay, I am interested to find out what is the voltage here. I am interested to find out what is the voltage here. That means this is now the response and obviously this is the excitation. Okay, now I am saying that I want to find out what is the voltage here. So will I short it and write what is the voltage here? No, because if it is short it means that the voltage is going to be equal to 0. No, I will not have to do that. What I have to do is I have to open that. I have to open that, sorry. Yeah, I have to open that. So I open it, and how do I open it and how do I keep it? No, what is the, again, the rule that I follow is whatever is the positive part that I keep as positive, whatever is the negative part I keep as negative. Okay, and this is going to be my V. And similarly here it was plus minus V. So I want to find out what is the voltage here. So where will I keep this voltage source? Where will I keep this particular voltage source? That is something that I have to know. Clear? For that, look, that the voltage was across this, isn't it? So this voltage, this excitation should also be across this. So I cannot draw it something like this. No. What I have to draw is, I have to draw the voltage source across it. So how will I draw that? I will draw that voltage source like this. So this is going to be the voltage source. Okay, this is going to be the voltage source. Now if it was a current source, what would have done? What would I have done? If suppose this was a current source, sorry. If suppose instead of the excitation being, as again it's a voltage here, so let me draw it like this. Um Suppose I am interested to find out what is the current flowing here. Where? Here. And suppose if here I am having a current source like this. Okay. So I want to interchange the excitation and the response. So what will I do? The response has to come here. So I will draw it in the same direction that I am drawing the current. I will draw it in the same direction. So the current direction is like this, I will draw it like this. And here the current direction is like this. So the source that I am going to draw, again I am going to draw it. Oh. Okay, let me. Yeah. I will draw the source, current source here like this. So I have again taken care of the direction. Okay. Now instead of current, if I would have to find out what is the voltage. Okay. So let me draw this. Okay. Suppose I was interested to find out, because of this current source, what is the voltage that I have to draw. I have to, what is the voltage that I will keep here. I'll have here. So again I have to interchange the current source with the voltage source. So voltage source, if I have to put here, I cannot short it, I'll have to open it up. Okay. Why? Because this is the not voltage source, I have to keep this voltage here. So this is going to be, again the current is going from positive to negative, so plus minus V. The current is going from positive to negative, so plus minus V. And here it is going to be, the current is in this direction, again going from positive to negative, so the current direction should be something like this. Then only it will create a voltage of plus minus, sorry, not in this direction, the direction I have to change. Why I am changing the direction, I will explain that, just hold on. I'll have to draw the direction like this. Why? Because this current will come and it will pass through this one like this. Correct? This one will come out. It will obviously flow here, here, everywhere, but it will also come down. And come down, the direction will be like this. Then this will be positive and this will be negative. That is what we want, isn't it? Correct? So that is what we do. Okay, that is what we do when we want to interchange the what do you say, the direction. And similarly here also the direction should be opposite. I have again made a mistake here. So here it should be positive here and negative here. Okay, why? Because the current that is coming out of this source, again it should have gone like this. Okay, so this you have to take care. Okay, once we do problems, we will understand it. See, I understand that you might have not grasped the direction in which it has to be drawn. I have shown all the possibilities, all the 4 possibilities I have shown. You can once again go through the video and note it down somewhere. Okay, thank you.